Hello friends, how are you? In today's video, we will see how we can perform application security testing. We will understand SAST, SCA and DAST in this journey. So let's start. Okay, so first introduction to our application security testing. What is the application security testing? So in our application, there are maybe many type of vulnerabilities are there which can lead to threats and breaches to our application. We can face this kind of attacks in our application. So to recognize this facts before our website or application is being actually been hidden, so we use some tools, and there are many open source tools available for this purpose. So for this, to solve this purpose, to we use the application security testing. And application security testing is simple to find the vulnerabilities and threats and breaches in your application. We use is known as the application security testing. Currently, where I have till worked, we use three approaches, three techniques to find the application security testing. First is the static application security testing, that is SAST. It's a very famous one. Then we have software composition analysis, SCA. In the last, we have dynamic application security testing, DAST. So we will discuss them in detail in further slides. First one, SAST and SCA are run on the codes. After that, dynamic application security testing is run on your actual website or actual application when your code is getting deployed on your application. We will see in further slides. So let's start with the SAST. What is the static application security testing? The first keyword is static, suggest like that it's going to be it's just running on some parameter which are not going to change. Like you have a Java application, .NET or whatever application you have, you write some code for it, for its functionality and some other things, how it will behave. So when we perform the application security testing in our DevOps lifecycle, that is, you write the code, then it's build, then we deploy it to somewhere. So when you write the code, it run on your code when it is in deployment phase. So you can early get the feedback that these things is need to be corrected in your application. So the main feature, how it's first about the definition is very simple. So it's analyze the code, analyze the code to find the vulnerabilities, and when it is in deployment phase, it's not, is really you have added to your application, then how you have written some code without the execution of code. It examine the code, give you some, like these are the vulnerabilities, these are the code coverage and reliability rating and other things, multiple things are there. So benefit, as you can understand, that you are getting the feedback or reports very at the very early stage. And if you are resolving the issue at the start point, then it will boost your speed and to stable, give you stable output. So it help you to be cost effective, that like that the stable code which you will get in the 3 to 6 months, you will possibly get it in the 1 or 2 months, as you are getting the uh, automatic feedback. And if we talk about the tool, we can there is a very popular tool, if you can see on the slide, it's a Sonarqube, and other one is a Checkmax. Sonarqube is very popular among the organizations. It's an open source tool. Community version is available. It's also have the paid version, and some clients do use the paid version. But for the starting, if you are just going to start your organization, you are a startup, you can use the uh, get leverage the benefit of the Sonarqube of the community version. So SAST is the Sonar Cube. You can see on screen. It is a I have done the Sonarqube analysis on application. It's Java application on via Azure DevOps. You can do it manually also, but we will discuss about what are the benefit of using CI/CD to implement these checks or tests. So it's a report, like it's a bug have 0, vulnerability is 0, code smell is also 0, coverage they have not included the currently, as this very new, they are very new clients, so currently they are not have written the test cases, so their coverage is coming like 0. But the other things, they are it's scanning bugs currently, the code which is they have run. And you can select, we have different quality gate. You can have the option to select either you want to scan the whole code or you just want to scan the new code. You have both the options available. That's the SAST. Then we move to the SCA. SCA is other tool which we run on the source code. Somewhere SCA, I implement SCA before Sonarqube in some CI/CD cycle. Like it give you detail of the libraries, third-party libraries which you are using in your application. There are multiple libraries which you call, like you are building a Java application through Maven. You can see there are multiple libraries they are downloading. So is this whatever the dependency you are downloading, library you are downloading, are they known for any open vulnerable issue? There are a database, NVD database, which where the organization keep the detail and continuously post the detail, what application, what dependencies vulnerable to which vulnerability, their ID is given, and a version is tagged like this version. This vulnerability is still open or fixed. Then you get the detail that in which version it get fixed, and you are using on that you can match, and after that you can advance your setup to that library after checking the things like the desired output which you was getting through your code is not getting affected. So, and as there are multiple dependencies which can, like this function is not available, some things, some syntax or some multiple things gets changed, so you have to look for that. But you should go for the version which is free from the vulnerabilities. So when you can execute it through whenever you are doing the development. Either you can do it earlier from the Sonarqube or after the Sonarqube, or if you are using any other static analysis or using. Currently I'm just covering this 3 tests only. So how it's work? I have already explained. It's scan for the non vulnerabilities, like whatever the vulnerabilities which is visible in the we can say scan for known vulnerability, which is available in the list of the NVIDIA database. It will give you detail that you are using these vulnerabilities and these are open to you. If I talk about the SCA, like you are using the Sonarqube. On Sonarqube, you have to when you are executing the Sonarqube's analysis, you have to execute on the whatever the source code you have. In the SCA, you can execute on code. Plus, if you are making a Docker image or whatever the containerization, you can also do that. So it work on both. Benefits. What are the benefits? Like whatever the open source component you are leveraging in your application, they are safe or not. This give you complete information. Then if the vulnerabilities or your library is outdated, you can also see that, and then you can move to the next branch. So popular tool, if we talk about what are the popular tools we have OWASP dependency check, then we have Trivy. Both are open source available. While implementing OWASP dependency check, I found a we can say problem. If you have the hosted agent, then it's okay. You can because it's take very long time to get the dependencies or data from the NVIDIA database. Trivy also take time, but Trivy scan will get completed within 1 to 2 minutes. But OWASP dependency check takes it might take above than 30 minutes to 40 minutes in the if you are using the Azure hosted agent. In some cases you might be using, so you can leverage these two tools for the SCA component. This is the you can say snapshot of the Trivy scan performed on the, I think it's a Nginx image of version 1.19.6. So it's saying the some libraries like apt, bash. There are different libraries it is using. Whatever the vulnerabilities have, it's giving their ID. You can then search for this ID. What it's how it can affect your functionality, your application. Then it give you whatever the version you have installed. Here in this version, it's not given the fixed version, but it give mostly the in which version it get fixed, or if it is open or not. Then we have the DAST. It's very different from the other two. Like think about the Java application. You have a Java application. You are building it through the Maven one. Then you get some jar file. That jar file you have deployed on a machine. For example, Azure App Services virtual machine. Then it came live. Then you execute this step. So after CI and deployment, CD part also done. So first to us the parts of the CI, it is a part of CD. So definition, testing and application. When it is a running state, everything is came live during after deployment. So it will be after, always after deployment. Means your CD pipeline is still running and you are doing while that testing. How it's work? It's stimulate some attack on a live application. So when you performing it on live, it have some disadvantage. So you have to be very cautious about that. Then you can first leverages this on your UAT and stage, that how things will work. Benefit, there are some vulnerabilities or some dependency, whatever you can say, that's not comes in when we do this. There are some problem with your setup, what you have achieved. which you can't know when you do in the SAST. So that's the problem which DAST is solving. That when your application is exactly running, how, like you have a box which is accepting user and password, and whatever the possibilities of getting its vulnerable, getting attacked. So this kind of things, like a application, like I am think of, like you have a website via name, your name, YouTuber viewer name, or tech on target subscription.com, subscriber.com, and this your website is live. I'm the hacker or the attacker comes to your website, and I'm looking for the way where you have done the, where from where the door is open, and I can enter and get the data. So in that way, same in that way it's work. It's don't know about your code, how it or application is in Java or whatever. It, these application know nothing, that whatever the application you have, whatever the uh, in which library you're using, it's know nothing. It's just like a normal user, it's coming, and how a normal user finds, look for to find the way to attack on your website, same way it's work. So it's give you the more things which only be lookable when you do it on the real time. So the famous example is burp suit and OWASP JAP scanner. I use OWASP JAP in some clients. So OWASP JAP is also open source and very easy to use. So it's give you a report in the HTML format. Here you can see uh, it scan a URL, then it's telling me high risk are not available on this website, or my web page are not there. But there are some medium level of alerts are some problems are there, and low level. Then there are some information kind of that you should look at that. Then after that, it's after the summarize, it give you the more detail, that what are the issues. Like in the medium we have seen, there are four kind of alert: missing like content security policy, CSP header not set, missing anti clickage header, then sub resource, and vulnerability GS library. These are the four which are comes as the medium alerts. And under that alert you have different instances like 5 5 5 10 1. So my application is one, and under that it have some functionality which have given its five kind of response, which are which falls under the content security policy. Then you can see sub resource one, it's have some like it's got some information which is for, and it's around 10 which is falling under it. Then GS library is only fine. Then we have the low one which someone to someone to. Then after that, this report you will get further more detail in what is the like for this content security policy. That's it is was there. Now you can how to resolve that, whatever the links it have used, and what are the path it has used to where it is showing this. So comparison of SCA, SAST, SC and DAST. Before doing the comparison, SAST, SCA and DAST have their different we can say different role in the testing of your application. And by using this all, you can make your application very secure and complete. If I think about a complete setup for the vulnerability scanning, SAST, SCA and DAST are both three are required to fulfill that. Like if you're doing SC and SC as SAST and SC only, then you are going to miss something. It's not like that complete. So SAST, SC and DAST, it's a For me, it looks complete system now. So here, if we talk about some critical point or the main point, so SAST is the code analysis without execution, and it's analyze your whole code. On the other hand, SCA not analyze the code. It's just for the open libraries, components you are using or calling via code. It's looking for that. And DAST, in the last, you have write the code, you have done the check open source, and after that you are deployed it to some machines where your application is now live and accessible to your user also. Whatever the user, like you have a banking website, then your clients are your banking user. So this is the first one. SAST is you can use at the early stage, at most where you can use, like you can use secret scan before that, and after that you can use the early stage. Then you have the SCA, then throughout the deployment you can use. For one thing I want to add here more, we have talked about the Trivy, which you can use for SCA. Trivy also do the we can say credit scanning. Any you are using anything of credential like of thing. Then we have DAST, post deployment. That's we have already discussed. So it should be post deployment. You during the CD pipeline when installing, but after the deployment. There's then we have last one, finds coding error. Either your quality is low, vulnerabilities also give, code smells is giving, and multiple things it's analyze and give. So SAST is like that, coding error. Then SCA, find vulnerabilities on your open source library. So to look for the runtime vulnerabilities, we use the DAST. Here in the DAST, if we have talked about the OWASP JAP scan, I want to add more thing. When we do these scanning of the OWASP via OWASP JAP, we have to give some option. It's a basic scan, full scan, and API scan. So basic scan is it's not, when we do the basic scan, it's not actually attack on your perform attack on your server where your application is hosted on your URL. It just look for the, like, if this attack is going to be happen, and what are the base from you are getting the vulnerable. So it's get completed in around 1 or 2 minutes, and you can consider it as a smart scan. But when you do the full scan, it takes around the 10 minutes, or also depend on your code and other things, on the website features, and but it takes around the 10 minutes, and it's actually stimulate the attacks in this full scan on your database, on your websites. So performing the full scan on your prod should be prohibited. Full scan mode you can do on the UAT and stage, not on the prod. So on the prod you can, basic is enough, and not go above basic. For it can vary upon depending on your requirement or the structure of your application. And in the last, we have third option also. Let's also discuss it. It's the API one. Like you have a URL which is hosting your multiple APIs. So how the API you can scan it via baseline also, but it's not giving that much of coverage. What I've seen or what I've observed, as they're also giving is for API only. So you should, when you are scanning the API, you go for that option. Last thing, when you are scanning the API, it what you have to do, it's actually execute your API, and whatever the result is, observe the result and give you the some details, like here we are getting the for our URL. So be conscious about that. Like when you are executing on the API, there are some API which need to be executed on some time basis. So if you are running the OWASP on that basis, it will get executed on the wrong timing. Like we have scheduled it for every night 10 p.m. but it gets scheduled your CD process. You are CD doing the seeding in the 7 p.m. So you can think about these terms. Then we have already discussed comparison. So integrating SAST, SCA and DAST in CI/CD. So integration is very easy. Either you are using Azure DevOps or whatever in Jenkins and other tools are there. It's very easy to integrate them. There are multiple blocks of to integrate CI/CD with the tool. So where you are doing the build stage, put the SAST and SCA there, and then you in the deployment stage. After the deployment task, you put the DAST task there. Benefit, why the benefit? Like you are running a code. So I think your developer not going to check the Sonarqube lint, and there are multiple tools available to check the thing, but they are not. It's become headache for them. But so while doing integrating with the CI/CD, you just integrate with the CI/CD, and then it will do SAST, SC, and DAST, and you can make the stage fail basis on the checks. So if your application rating is getting like quality gate is not getting fulfilled, you can make the stage down or particular step down. So you can do in that way. And early detection and remediation of vulnerability. If you are not going to use this feature on your for your application and not in your CI/CD, there will likely be to miss, because we have the habit of skipping things as a human being. So integrating CI/CD with these steps is very crucial to make your code stable and application error free as much as possible. To summarize me, what we have understand what is the application security testing. We have discussed the terminologies and technology, whatever the SAST, SC and DAST. So final thoughts: implementing component security testing in deployment and deployment pipeline are very crucial for getting the error to be recognized, at least recognized. If you're not going to fix at that time, but your organization, your know these vulnerabilities you have, either if they are coming in sometime after that, when new version are getting uploaded and new version are vulnerable to some dependencies. So that's all for the today video. To implement the demo, we will look for some other time. For today, thank you for being. Thanks everyone.